Alright, folks, on Eastern, thanks for watching this. I think the best way to explain the current situation is going to be through a video because there's just too many graphics that I want to go through to just put it into a post. So I've went ahead and posted this up on YouTube, and hopefully you guys can see it and will give the explanation. As always, questions, comments, or anything else is welcome and appreciated, so you're welcome to do that. So what we're going to look at here is the setup for March 5th, 2008, and we're going to just highlight the players that are on the field right now. We've got this is the Big Kahuna, this is the upper level disturbance in the subtropical jet that is going to be moving its way out into the midsection of the nation this weekend, and will eventually be honestly the biggest problem for our system becoming a strong system. Now we have the disturbance, very nice strong trough that's going to be diving in into the southwest and really creates that full latitude trough, and it's the southern piece of this trough, this piece of energy right in here, that's going to eventually cut off and create the big storm where we get the cutoff low that's going to go up somewhere in this area in here. So there's really is a lot of discrepancy in my mind, at least, as to where this cutoff low is going to track. And I'm going to explain to you why. I just sort of highlighted the area where I think it's possible. So let's go ahead and talk about the players on the field first. Again, you have this piece of energy in the southwest that comes out into the plains, and then it basically cuts up on the east side of the developing trough. That is one of the biggest problems to the system. The fact that this is not phasing in with the main feature, which is sitting back here, but it is instead cutting up on the eastern side. We've seen successive runs of the GFS continue to track this system further and further back. I believe if you go 5 or 6 days in advance, it was already expected to be in this area at this point. So definitely, we're seeing a trend in that method. It still is, again, you can see if you took this trough and if you were considering this to be a full latitude trough at this point, it is definitely a negatively tilted trough. But what we're going to see is that this system sort of comes down in here before it ejects out to the northeast. So it's not going to necessarily be it's going to try to be a little bit more phased in, and we're going to see that on the next couple of graphics. And then what you have is you have the southern part of this disturbance. It basically, as of the latest runs, it comes down into here, it cuts off this piece, which is another key player, comes in here, gets a negative tilt right around, whoops, sorry about that, gets a negative tilt right around in this area in here. And that is one of the other key reasons why there's a little bit of a problem with this system producing a big snowstorm for the East Coast. I believe that the model may be feeding back a little bit too much and trying to develop the jet a little bit too strongly out here in front of the system. And I'm gonna go ahead and go through the graphics and explain that. This is not to say that we're gonna get a blizzard along the East Coast, but definitely we've seen some trends in the models that have been trending away from the strong storm up into the Midwest, like was originally forecast. So now that we've got a good look on the players in the field, oh, I forgot to mention one of the biggest ones, the Clipper that's coming through now is going to go and bomb out off the New England coast. And actually the way that this bombs out and the configuration of this is going to be our 50-50 low in here. The configuration of that thing eventually bombing out is very key. Where that sets up as to where we can get this this ridge in here is going to be transient, move northeast. This thing's going to bomb. This is going to start to create a block. There's another block coming over the top, and they are going to sort of help create the block that's going to keep this storm in place and allow it to cut off from the main flow. So let's go ahead and take a look back. What I'm going to do is I'm going to step through in succession from oldest to newest, the GFS. This is going back almost, I want to say, this goes back to the 27th at 12Z is the first map we're going to look at. And we're going to look at what the GFS was doing. We're looking at the 250 millibar layer. Because the dynamics with this system that are causing problems are jet level and not at the H5 level. So here's what we see. This is really a nice setup, actually, and we saw something similar to what we'd wanted. There's a good jet coming from behind. The jet is on the east side of the trough is there, and that's not necessarily what you want to see this early in the game. but it's pretty far south, so that creates a decent diffluence setup down here. It's not great, and that's why we didn't see the ultimate solution that we want to see, but it's decent. This is when you get this intersection like this of the two jets, that's definitely very positive for a big storm formation. But look at what's happening. We have this initial piece of energy is all the way out here. Which is this is not to be confused with the storm that's coming from the south. The initial piece of energy that's sitting in here is a disturbance, the northern part of this trough that sort of just comes across the quote-unquote clipper part. So we have this disturbance sitting in here, and we already have a strong negative tilt on the northern side of this trough. This is definitely lifting. It's feeling this ridge in here. It's feeling the block, and it needs to go somewhere. So what's the GFS do? It tries to separate the darn thing, and that's why you get the whole thing to cut off from the flow to begin with, is because this piece is staying separated.